Hi everyone. Previously in this course, we discussed with Mustafa al the surface anatomy and the blood supply of the brain. Today in this lecture, we will move on together to another important topic, which is the cerebral venous system. I am Mahmood F, Al-Zaidy, 40th stage medical student at College of Medicine, University of Baghdad. I trained in 7th House Neurosurgery Mentorship Program and a scientific officer at Walter E. Danty, Iraq. As you know, cerebral venous system is the most complex draining system in the human body. And the veins of the brain composed of two major groups. The first group is the superficial veins group, and the second group is the deep veins group. In this lecture, we will focus on superficial veins group into 4 different levels. The first level is the cortical veins, bridging veins, dural sinuses and veins, and lastly, anastomotic veins, while the deep veins composed of 3 groups: ventricular group, cisternal group, and the great vein of Galen. Starting with superficial veins group. This group drains the cortical area, or the superficial surface of the gray matter of the brain. As we said, it's composed of 4 types or 4 levels of veins. The first level is the cortical veins. The cortical veins is small veins arise in the sulci and gyri of the brain, and it's divided into 3 groups based on whether that they drain the lateral surface, medial surface, or inferior surface of the brain. And the cortical veins of each surface also divided according to the loop that they drain and the area. In these 2 schematic figures, we can see the lateral surface of the right hemisphere of the brain. This is the anterior sides, and this is the posterior sides. In this figure A, we can see the territories of each vein, while in the figure B, we can see the direction of each vein. The vein of the lateral surface of the frontal lobe divided into ascending group and descending group. The ascending group composed of a frontopolar vein here, the most anteriorly and most inferiorly. Anterior, middle, and posterior frontal veins, and lastly the precentral vein. And these veins or this group drain into superior sagittal sinus, while the descending group composed of 1 vein, which is the frontosyllabian vein, and this vein drain into the superficial syllabian vein. In this figure, here we can see the ascending group shades with light blue, and the descending group shades with dark blue, and this is the superficial syllabian vein. The medial surface of the frontal lobe divided by the cingulate sulcus into inner zone here and outer zone here. And the veins of this surface also divided into ascending group and descending group. The ascending group composed of anteromedial frontal vein, centromedial frontal vein drain this area, and posteromedial frontal vein, and a paracentral vein which drain this area, and this group also drain into superior sagittal sinus, while the descending group composed of the paraterminal vein which drain this area, and anterior pericallosal vein, and here in this figure the anterior cerebral vein, and this group drain into inferior sagittal sinus and basal veins. The inferior surface of the frontal lobe also divided into anterior group and posterior group. The anterior group composed of 2 veins, which are the frontopolar vein drain this area, and anterior frontoorbital vein, which drain this area, and this group drain into superior sagittal sinus. While the posterior group composed of posterior frontoorbital vein, which drain this area, and olfactory vein. And this group drain into the basal veins. Here in this figure, this is the anterior group, and this is the posterior group. Backward to this figure, the lateral surface of the parietal lobe, which shades with orange and blue here. The veins of this surface also divided into ascending and descending group. The ascending group composed of the post-central, anterior, and posterior parietal veins, and this group drain into superior sagittal sinus, while the descending group composed of parieto-Sylvian vein, which is drained into the superficial Sylvian vein. Here, this is the ascending group, and this is the descending group, and this is the superficial Sylvian vein. While the medial surface of the parietal lobe also divided into ascending and descending group. The ascending group composed of two veins, which are the anteromedial parietal vein and posteromedial parietal vein, and this group drain into superior sagittal sinus, while the descending group composed of posterior pericallosal vein, and this vein courses posteriorly around the splenum of the corpus callosum. This is the splenum of the corpus callosum, and drain into the vein of Galen. In this figure, this is the posterior pericallosal vein, and this is the vein of Galen. And the lateral surface of the temporal bone, also divided into ascending and descending group. The ascending group composed of the temporosylvian vein, it drain this area, and this vein drain into superficial Sylvian vein. Here, this is the temporosylvian veins, shades with light green, and this is the superficial Sylvian vein. While the descending group composed of anterior temporal vein, middle, and posterior temporal veins, and this group drain into tentorial sinus. While the medial surface of the inferior surface of the temporal lobe also divided into lateral and medial groups. This is the medial surface of the temporal lobe, not this is the inferior surface, not the medial surface. We can see it here. This is the lateral group, and this is the medial group. The lateral group composed of a posterior temporobasal vein, middle temporobasal vein, and anterior temporobasal vein, and this group drain into tentorial sinuses, while the medial group composed of medial temporal vein, anterior hypocampal vein, and ankle vein, and this group drain into basal veins. Lastly, the occipital loop. The lateral surface of the occipital loop is drained by one type of veins, which is predominantly ascending veins, and these veins are called the occipital veins. In this figure here, we can see the occipital vein. It's ascending vein, as we said, and it courses forward rather than backward, and it's near. There is no large vein. It drains into superior sagittal sinus below the auricular hair of the leaf in a distance of 4 to 5 centimeters. These veins drain into superior sagittal sinus. While the medial surface of the occipital lobe also divided into ascending and descending group, or an anterior and posterior group. The anterior group drained by the anterior calcarine vein, and this vein drained into vein of Galen. Here, this is the anterior calcarine vein, and this is the vein of Galen. While the posterior group drained by posterior calcarine vein, and this group drained into superior sagittal sinus. The inferior surface of the occipital loop is drained by the occipital-basal veins, and these veins drain into tentorial sinuses. And this vein was the last vein of the cortical veins of the superficial veins of the brain, which is the first level or the first type of the superficial veins. Moving to the second level or the second type, which is the bridging veins. The bridging veins are usually short veins, and these veins extend from the terminal end of the cortical veins until reaching the dural sinus that they drain into. we have four veins, or we have four groups of the bridging veins. The first group, called the superior sagittal group, you can see here these short veins, shades with dark blue, along the superior sagittal sinus. This is the superior sagittal bridging veins. It's short veins, approximately 1 to 2 centimeters long, and it's extend from the site of exit of the cortical vein from the arachnoid mater until reaching the superior sagittal sinus to drain into. The bridging veins sometimes composed of one cortical veins or maybe more than one cortical veins merged together to form one bridging veins. This superior sagittal group drain parts of anterior frontal, parietal, and posterior occipital lobes. If you remember, the anterior group of the inferior surface of the frontal lobe and the ascending groups of the medial and lateral surface of the frontal, parietal, and occipital lobes drained by this group. The second group, we can see it here, shades with red. It's the sphenoidal group. It's formed by the terminal end of the superficial Sylvian vein and occasionally deep Sylvian vein. And this group drain into Cavernous Sinus or Sphenoparietal Sinus. It's drain parts of frontal, temporal, and parietal lobes. While the third group, shades with the green here, it's the Tentorial Group. This group drain into the lateral tentorial sinus or the transverse sinus here or superior petrosal sinus. And this group drain parts of the temporal and occipital lobes. While the last group or the fourth group is the pulsing group, shades with purple here. The pulsing group formed by the veins that drain into inferior sagittal sinus or into basal veins or internal cerebral veins or great vein of Galen. This group drains the limbic lobe and the largest cortical area that is drained by this group is the cingulate gyrus and parahypocampal gyrus. And this is the second level of the superficial veins. Here in this figure, it's a real cadaver figure. This is the anterolateral view after injection with latex in the internal jugular vein. Here we can see the cortical veins. This is the cortical vein along the sulci and gyri of the brain, and from this side, which form the site of exit of the cortical vein from the arachnoid mater until reaching this site, which is the superior sagittal sinus. It's the bridging veins. This is the bridging veins. And here we can see the vein of Trollard, which is the anastomotic vein. In this figure, the superior view, this is the superior sagittal sinus, and this is the cortical veins and the bridging veins drain into superior sagittal sinus. Now moving to the next level, which is the third level or the third type of the superficial veins of the brain, which is the dural sinuses and vein. The dural sinus is space between two layers of the dura mater. In this schematic drawing, we can see the coronal section of the brain, meninges, and the skull. This is the cortex of the brain. This is the pia mater, subarachnoid space, arachnoid mater, and this colored with the gray is the dura mater. This layer of the dura mater called the meningeal layer, while this layer is the endosteal layer. And between these two layers, this space forms the dural sinus. Here we can see cortical vein in the subarachnoid space, and from this side, the site of exit of this cortical vein from the arachnoid mater until reaching this superior sagittal sinus, it's the bridging vein. Here, meningeal vein, and this is diploic vein, emissary vein, and so on. In this figure, we can see the dural sinuses of the brain. Here, the superior sagittal sinus in the midline, inferior sagittal sinus, straight sinus, right transverse and left transverse. Here, sigmoid sinus. And from this side, this is the Sphenoparietal sinus, Cavernous Sinus, and here superior petrosal sinus, inferior petrosal sinus, and this the basilar sinus or basilar plexus. Here the marginal sinuses, occipital sinus, and this venous structure. It's from the confluence of sinuses. It connects the superior sagittal sinus with two transverse sinus and straight sinus and occipital sinus. This venous structure called the auricular hierophyly. Remember this name. Starting with superior sagittal sinus. The superior sagittal sinus courses in the midline. It's originate just behind the frontal air sinus and continues posteriorly until reaching the auricular hierophyly to drain into transverse sinus. The superior sagittal sinus may communicate through the foramina cecum with the veins of the nasal cavity, and it may drain equally into right and left transverse sinuses, and it may drain predominantly or wholly into one transverse sinus, either right or left, but it's predominantly drained into the right transverse sinus. This is the superior view. This is the superior sagittal sinus. This is the cortical sinus and the bridging veins. Here, the superior sagittal sinus also, and this is the posterior view. This is the superior sagittal sinus, and this is the right transverse sinus and left transverse sinus. And as we said, the superior sagittal sinus drain predominantly into the right transverse sinus. Lastly, in the superior sagittal sinus, this venous structure adjoining the superior sagittal sinus, it's a dural space, receive the blood from the meningeal veins to drain into the superior sagittal sinus. That means the meningeal veins drain into this venous structure, which called the lacuna or lacunae, and from the lacuna it's drained into superior sagittal sinus. The lacunae may be separated, and the largest lacuna seen in the parietal region and into the posterior frontal region, while the smallest one seen in anterior frontal and in occipital region. And this separated lacunae may be replaced by one large lacuna on each side of the superior sagittal sinus. The cortical veins and the bridging veins run beneath the lacuna to drain directly into superior sagittal sinus, or through common opening to drain together into superior sagittal sinus. Sometimes, and few veins drain directly into the lacuna, and from the lacuna drain into superior sagittal sinus, but it's rare. Here we can see the superior sagittal sinus and lacuna, and this is the bridging vein and cortical vein. It drain and run beneath the lacuna. The inferior sagittal sinus and citrate sinus. The inferior sagittal sinus originate just above the anterior portion of the corpus callosum here in the inferior margin of the pulse, and it's continuous posteriorly until reaching the sigmoid of the corpus callosum to join the great vein of Galen and form the citrate sinus. The inferior sagittal sinus may connect with the superior sagittal sinus through venous channels and the pulse, and this connection in some cases may be so large that the superior sagittal sinus predominantly drain into inferior sagittal sinus. Behind the sigmoid, in this area, the junction of the great vein of Galen and inferior sagittal vein, it's the origin of the transverse sinus. The transverse sinus from here courses backward and inferiorly on the tentorium in the junction between the tentorium and the falx cerebri, and continuous posteriorly until reaching the auricular hierophyly to drain into the transverse sinus. The citrate sinus may drain into either right or left transverse sinus, but it's predominantly drain into the left transverse sinus. The sigmoid sinus or the transverse sinus. We mentioned this structure before. It's the auricular hierophyly. We said this venous structure connects and form the confluence of the sinuses. From this structure, the right and left transverse sinus are originate. The transverse sinus run laterally in the site of the internal occipital protuberance and in the site of the attachment of the tentorium into the inner surface of the occipital bone, and continuous laterally until reaching the edge of the petrous bone. Then it's leave the tentorium and continuous as the sigmoid sinus. Here in this figure, we can see the landmarks of the transverse sinus. This is the union of the occipital bone. Just behind the union and slightly above the origin of the right and left transverse sinus. And in surgery, to avoid the injury of the transverse sinus, the approach should be 5 millimeter below the origin of the semispinalis capitis. And that's commonly in the surgeries of the posterior fossa and fourth ventricle. The right and left transverse sinus are not necessarily symmetrical. Normally in the males, the right transverse sinus is slightly larger than the left, but in some variation make the right transverse sinus 4 times larger than the left. And the vice versa, if the left transverse sinus larger than the right, and that especially in the cases of a large connection between superior sagittal sinus and inferior sagittal sinus, that make the superior sagittal sinus predominantly drain into inferior sagittal sinus, then to citrate sinus, and then to the left transverse sinus. The sigmoid sinus is a continuation of the transverse sinus. It's in the site of leaving the tentorium. When the transverse sinus leave the tentorium, it's become the sigmoid sinus and run in S-shaped groove until reaching the jugular vein to drain into. In the course of the sigmoid sinus, at the beginning, the superior petrosal sinus drain into the sigmoid sinus, and in the end, the inferior petrosal sinus drain into it. The sigmoid sinus in the males is slightly larger and more laterally and posteriorly than in females, and this may be due to the difference in size of the cranial base between the sexes, and in the comparison between the right and left side of the sigmoid sinus, the right side is larger and deeper and greater in the cross section, and this may be due to the fact that the right side is the dominant side of the venous drainage. Here in this 3D CTA image, we can see this is the sigmoid sinus and S-shaped groove until reaching the jugular foramen. On each half of the tentorium, there is two sinuses. It's called the tentorial sinuses. Here the lateral tentorial sinus and here the medial tentorial sinus. We can see is here, this is the lateral tentorial sinus and this is the medial tentorial sinus. The medial tentorial sinus receives the deoxygenated blood from the cerebellar node cerebellum. And the lateral tentorial sinus receives its drainage from the occipital and temporal lobes. The lateral tentorial sinus here drains into the transverse sinus, while the medial tentorial sinus drains into citrate sinus, or the junction between the citrate and transverse sinus. The cavernous sinus, it's situated on each side of the sella turcica. This is the size of the sella turcica, and this is the dorsum silli. This the right and left cavernous sinus. The cavernous sinus is connected with each other anteriorly and posteriorly by intercavernous sinuses, and it's connected anteriorly with the ophthalmic vein. Here's the ophthalmic veins, and in this figure, the sphenoparietal sinus. In the middle sides of the cavernous sinus, it's connected with trigoid plexus through small veins pass through the foramen spinosum and the foramina ovale. And in the posterior parts of the cavernous sinus, it's connected with superior petrosal and inferior petrosal sinuses and with basal sinuses. The sphenoparietal sinus, it's situated here, just below the edge of the sphenoid bone. It's connected laterally with meningeal veins, and it's drained into the anterior part of the cavernous sinus. This is the superior petrosal sinus, and it's originated from the posterior parts of the cavernous sinus and drained into sigmoid sinus. And this was the third level of the superficial veins of the brain. Now moving to the last type of veins, which is the anastomotic veins. We have the three anastomotic veins, which are the vein of Trollard, vein of Labi, and superficial Sylvian vein. These veins connect the superior sagittal sinus with the sphenoparietal sinus and with tentorial and the transverse sinuses. The vein of Trollard, it's the post-central vein, post-central cortical vein, And the vein of Labi, it's commonly the middle or posterior temporal vein. And this is the superficial Sylvian vein. These veins may be symmetrical or may be different in the size. Maybe one or more anastomotic veins are dominant and the others are small or absent. In this case, we can see the Trollard vein. It's a dominant vein and it's connect the superficial Sylvian vein with the superior sagittal vein. It's dominant in this case, and this is the vein of Lavi, also dominant, but the superficial Sylvian vein is small. Here in this figure, the dominant vein is the vein of Trollard and the superficial Sylvian vein, while here the vein of Lavi is small. And in this figure, figure C, the only dominant vein is the superficial Sylvian vein, while here the only dominant vein is the vein of Lavi. In these figures, this is the lateral surface of the left hemisphere of the brain. This is the anterior side, and this is the posterior side, and this is the Sylvian fissure. Here we can see the superficial Sylvian vein. It's a dominant vein here. And this is the vein of Lavi. It's also dominant. And this is the vein of Trollard. It's small vein. While in this case, it's also a dominant vein is the superficial Sylvian vein and vein of Lavi and very, very, very small vein of Trollard. Here in this case, we have double or two vein of Trollard. This is the most anteriorly one, and this is the most posteriorly one. And this is the superficial Sylvian vein, and this is the vein of Lavi. In this case, the dominant vein is the vein of Trollard and superficial Sylvian vein, and the vein of Lavi are absent. Well, now moving to the second or the next major group of the brain, which is the deep veins group. This group, it drains the deepest white and gray matter of the brain. In this figure, we can see the difference between the cortical or superficial veins and the deep veins. Here we can see this is the superficial veins that drain the cortex of the brain. While here, the deep veins, which drain the deepest white matter and the gray matter. This is the lateral ventricle, and this is the caudate nucleus. Here, the site of the thalamus, and here the other structure of the basal ganglia that drained by the deep vein groups. As we said, the deep veins composed of three groups, which are the Ventricular Group, Cisternal Group, and the Great Vein of Galen. Here in this figure, we can see the lateral ventricle. This is the frontal horn, this is the body, this is the atrium, temporal horn, and occipital horn. The ventricular veins group composed or divided of two groups. The lateral group shades with the green here, and medial group shades with orange here. The lateral group composed of veins coming from frontal horn and the body, and these veins drain into internal cerebral vein. These veins like anterior caudate nucleus, thalamus-citrate nucleus, thalamus-citrate vein, and the thalamocaudate vein. And this vein, as we say, they drain into internal cerebral vein, then into the vein of Galen. While the veins from the temporal horn and atrium and occipital horn, it's drained into the basal vein. These veins, like the inferior ventricular vein, the lateral atrial vein, and so on. And these drain into basal vein, then into the vein of Galen, while the medial group. The veins that coming from the frontal and body and atrium and occipital horn drain into the internal cerebral vein. These veins like anterior septal vein here, the posterior septal vein, and the medial atrial veins. While the veins from the temporal horn drain into the basal vein, and this vein is the anterior longitudinal vein, and this vein in the atrium or the lower part of the atrium, it's also drained into the basal vein, and this vein is the posterior longitudinal hypocampal vein. The cisternal group. The cisternal group formed by veins that drain into basal vein of Rosenthal, and this group divided into 3 sites or 3 segments or 3 regions. These regions, these groups divided according or based on its relationship with the brainstem and the incisura of the tentorium. These regions are the anterior incisional region here, anterior to the brainstem, and the middle incisional region here. It's on each side of the brainstem, and the posterior incisional region posterior to the brainstem. Starting with the first region or first segment, which is the anterior incisional region, the deep middle cerebral vein and the frontal orbital vein join to form the basal vein of Rosenthal. Then this vein passes backward, and the sides of the optic chiasm situated here in these sides, and it's connected with each other by anterior communicating vein until reaching the anterior part of the brainstem. It's becoming or continuous as a middle incisional region or middle incisional vein, and this vein communicated in the anterior parts or on the anterior side of its course with the posterior communicating vein, and it's received some veins like the inferior ventricular vein here and medial temporal vein. Posterior to the brainstem, the posterior incisional region are originate, and it's received some veins like the lateral mesencephalic vein and internal occipital vein until reaching the vein of Galen to drain into. This is the great vein of Galen. It's one of the deep vein groups or the deep veins of the brain. It's originate here posterior to the brainstem and the junction between the basal veins and the internal cerebral veins from each side, and other veins like the anterior calcarine veins and other. It's run posteriorly until join the inferior sagittal sinus to form the straight sinus. Here in this figure, we can see the origin of the great vein of Galen. This is anterior sides, and here posterior sides. This is the inferior sides here, and this is the superior sides. This is the tentorium. This is the great vein of Galen. Here we can see the anterior calcarine vein, basal vein of one side, internal cerebral vein, the superior vermal vein, and basal vein of the other side, anterior calcarine vein of the other sides, joined together to form the great vein of Galen. The same thing in this figure. This is the anterior calcarine vein. This is the internal cerebral vein of one side. This is the basal vein of one side, and this is the basal vein of the other side, and this is the other side, the anterior calcarine vein of the other side. And here we can see the internal cerebral vein of the other side. Now we complete the venous system or the cerebral venous system. I need some student to answer this question or this quiz. Can anyone answer? Please raise your hand. Jafar. You are mute. Anyone? Mahmood? Can you describe this image?
Yes, this is sagittal section CT scan, brain CT scan, and enhanced with the contrast.
CT scan this? Or MRI?
No, this is MRI, I'm sorry. Yes, MRI.
Okay. A, can you know what's
A, it's superior sinus.
Okay. Jafar?
And now, is my voice clear now?
Okay, can you tell me what's from the B?
I think it's internal cerebral vein.
Okay, good. C?
Vein of Galen.
Okay, great. Anyone more can answer this? Mahmood?
Yes, Mahmoud. What?
E?
Straight sagittal sinus.
Straight sinus. And D?
The
venous structure that confluent the sinuses. What's its name? Auricular hierophyly.
Yes.
Okay. This is the reference, is the rotocranial anatomy and the surgical approach, and the other sides to the figures and the schematic drawing from some websites on the internet, like the Radiopedia and the Kenhub and others. Any question?
Well, thank you, Mahmoud, for this.